Hello, boys and girls, and welcome back. We are talking greatest common factor. I am in your book on page 127, greatest common factor. You're looking at the problems and you are seeing, in this case, now you're seeing the answers. So let's look at number 18. You're given two numbers, two values, 45 and 120, and look, they're giving us the answer there. Then also you see number 21. What happens if you get three digits? How do they find that four? I'm going to share my journal with you if I can. It's not letting me share. Let's take a look. Here goes our journal. So here is number 18. You're given these two values. First, let's make a list. I have a 1 and a 45. Those are factors because 1 times 45 is 45. I have 3. What is its partner? Is it 15? What else? How about 5? 5. What is its partner? It is 9. Are there any other factors for 45? Ready? Let's go on. How about for 120? I have 1, 120. Now, there might be a lot of numbers listed here in the list. So you could see when you get large numbers, a list may not be a great idea, but let's do it anyway. I have 2, 60. I have 3. Is it 40? How about 4? I have 4 and 30. How about 5? 5. How many? How many times does 5 go into 120? Valerie, how many times does 5 go into 120? Miss Baca says, I don't know. So I know it goes in there because I know my divisibility rules and I know that this is a 0 here, but I don't know what its partner is. So I'm going to pull this over to the side and I'm going to pull this over to the side and divide. 2 times 5 is 10, so it's 24. What about 6? Does 6 go in there evenly? Sure looks like it would, doesn't it? Would it be 20? 6 and 20. Any other numbers? What about 8? I think we got them all. Okay, so I want to look through this. Look at all the common factors here. The common factor, here's a 1, here's a 3, here's a 5. Do we see any other common factors? It appears that the GCF is the 5, correct? Let's see if a factor tree will benefit us. Do you see all those numbers we start listing there? Okay, let's try it this way. Let's see if this will be of benefit to us. Okay, 9 and 5, correct? This is still a composite number. So this is a 3, and a 5, correct? Do you see your tree there? Let's do this one. 12 times 10. 6 times 2. 5 times 2. These are already prime numbers, but not that one right there. So we need to keep going. 3, 2. I'm going to bring this one down, and there. Okay. Aha. Aha. So take a look. Here's a 3 and a 3. I have a 5 and a 5. So it looks like the GCF is actually 15. This is a great example. So let's look above. because above we thought the GCF with this big long list was going to be 5, but it's not. It's going to be 15. We see a 15 there, okay? Let's see. Oh, yes. So let's double check. 120 divided by 15. How many times is that? Is it 8 times? Oh, look at that. Oh, okay. So did you notice when we made a list with a long number, we had so many numbers down here that we missed this factor at 8 and a 15. So we miss these here. Do you see the benefit of a factor tree? I think once the numbers get really large, you might be better off down here. Usually if the number's below 100, you don't have any problem with a list. But this is a perfect example where you had all these factors listed here and we made a mistake. Let's double check our work here. It looks good. Excellent. Let us go on. Let's do another one. Okay, that's a really good example. This is a good example where the list has limitations. When you get a lot of numbers, it's possible to miss one, which we did. Take a look at the factor tree. I double checked our work here. It looks to be good. The GCF is actually 15. Excellent. Let us move on. What happens if you're asked to find the greatest common factor with 3 values? Let's take a look at this one. Let's do it with a list and a factor tree. So we have 1 and 20, 2 and 10, correct? Let us do 4 and 5. Are there any other factors for 20? I think we got them all. Ready? 1, 32, 2, and 16. And again, how I'm getting these numbers, for example, 2 times 16, that's how we're getting to 32. What about 3? No. How about 4? That one we know. 4 and 8. How about 5? No. 6, 7, and 8 we already have listed, so it looks like we have them all. It's okay if you have this gap here. I have 1, 44, 2, 22. What about 3? No, because I think my divisibility rules, I add these up, I get 8, and 8 is not divisible by 3. How about 4? Yes. 5? No, doesn't end with a 0 or a 5. 6, 7, 8. Are there any others? There are not. So when I look at this, and I didn't mean to leave that gap there, but you can clearly see what the GCF is. You have the triple peanut. There it is. Let's do it with a factor tree. So you have 20, 32, 44. Let's do all 3 of them. I have 10 times 2, 5 times 2 times 2. Let's take a look at the 32. This one's done. Let's do this one here. 8 times 4, 4 times 2, 2 times 2. This one is still a composite, so I have to keep going. 2 times 2 times 2 times 2 times 2. Looks to be 2 to the 5th, doesn't it? Let's do this one. 11 times 4. That one's already a prime number, but this one I see that I need to split those up. And now when you have three numbers, I'm going to do the same thing. Do any of them have a 5? Just that one. No, can't take another 5 from there. But I see they all have a 2, don't they? I put one down there. They all share another 2. I put another one down there. The GCF is 4. Did you see how to do it with 3 values? Notice up here, it's a little safer. When you're making a list and the values are below 100, I think that's a rule that we could use. If the values here are below 100, it's much easier to make a list of all the factors. Once the values get over 100, I think your factor trees are a little more reliable. Okay, that will be the end of part 2. So what I want you to do is I'd like you to try all the problems in the book on page 126 and 127. You do have those answers online. So try those. Then you check those answers. Then I want you to go on to your R and P page and then have Mom check those answers for you. Send me any questions that you may have.